Picture this. You step outside tonight, look up at the sky, and something feels wrong. That bright, steady light that's been hanging in the heavens for as long as humans have been alive is gone. Jupiter, the giant, the guardian, the planet that accounts for more mass than every other planet in our solar system combined, has simply vanished. No explosion, no warning, just gone. And here's the thing that scientists find deeply unsettling. The effects wouldn't all be immediate. Some would unfold over years, some over thousands of years. And a few of them would be so catastrophic, life on Earth might never fully recover. Welcome, fellow explorers, to Cosmic Story Lab. Tonight, we're running the most dangerous thought experiment in astronomy. Not because Jupiter disappearing is likely, but because understanding what it does tells us something incredible about why we're even here in the first place. Buckle in. This one gets wild. Before we can understand what happens when Jupiter disappears, we need to understand what Jupiter is. And trust me, the numbers alone are staggering. Jupiter is not just big, it's almost incomprehensibly big. According to NASA, Jupiter has a mass roughly 318 times that of Earth. In fact, it accounts for approximately 71% of the combined mass of all the planets in our solar system. If you hollowed out Jupiter, you could fit over 1,300 Earths inside it. Every other planet, Saturn, Uranus, Neptune, Mars, Earth, Venus, Mercury, all of them together would barely tip the scales against Jupiter. And that size comes with something even more powerful: gravity. Jupiter's gravitational field reaches deep into the solar system, tugging on asteroids, redirecting comets, nudging the orbits of other planets, and generally acting like the solar system's invisible hand, keeping everything in a kind of careful cosmic order. Think of the solar system as a city. The sun is the government, the central authority, the one everyone revolves around. But Jupiter is the police force, the traffic control system, and the city walls, all rolled into one giant ball of gas. Remove it, and suddenly the city has no rules. Here's something fascinating and a little eerie. If Jupiter disappeared right now, you wouldn't notice anything for about 43 minutes. That's how long Jupiter's light takes to reach Earth. So for nearly 3/4 of an hour, you'd see Jupiter exactly where it always was. Then, it would simply wink out. And the gravitational signal? According to Einstein's theory of general relativity, gravity travels at the speed of light. So the same delay applies. Earth wouldn't feel Jupiter's absence for those same 43 minutes. After that moment, Earth's orbit wouldn't dramatically shift right away. As the National Radio Astronomy Observatory has explained, Jupiter's gravitational pull on Earth is about 1/25,000th the pull of the Sun. So our immediate path around the Sun would feel largely the same. Look outward. Look at Jupiter's 95 moons. The moment Jupiter vanishes, those moons have no anchor. Ganymede, larger than the planet Mercury, the biggest moon in the entire solar system, would go flying off into space. So would Europa, with its vast underground ocean that scientists at NASA believe could potentially harbor life. Io, the most volcanically active world in the solar system, would drift away. Callisto, Himalaya, and dozens of others, all of them suddenly free-floating orphans in the dark. Some would spiral into new orbits around the sun, some might wander into the inner solar system. A few might eventually drift so close to other planets that their gravities would fling them even further outward, toward the stars. It's the end of a whole family of worlds. Just like that.
Now here's where things start getting genuinely frightening for Earth. Between Mars and Jupiter lies the asteroid belt, a vast ring of rocky debris, millions of pieces of it, left over from the formation of the solar system. And for billions of years, Jupiter's gravity has been the reason most of that debris stays put. Jupiter acts like a cosmic shepherd. Its gravitational influence constantly nudges, redirects, and crucially ejects many of the asteroids that might otherwise develop unstable orbits. According to research published in the journal Icarus, without Jupiter, the flux of dangerous space rocks crossing Earth's orbit could increase dramatically over long timescales. There's also a more subtle effect, something researchers call the Kirkwood gaps. These are specific regions inside the asteroid belt where Jupiter's repeated gravitational tugs have cleared out the rocks, essentially sweeping certain orbital paths clean. Without Jupiter, those gaps would slowly fill back in. And those newly destabilized rocks, some of them would head inward. Not all at once, not tomorrow, but over thousands and millions of years, Earth would face a significantly more dangerous neighborhood. We got a taste of what this cosmic threat looks like back in 1994.
The most dramatic event in modern astronomy.
Before I tell you about the comet that showed us exactly what Jupiter is protecting us from, and trust me, the scale of what this thing would have done to Earth will make your jaw drop. If you're finding this genuinely mind-blowing, hit that like button right now. It takes 1 second, but it means the world to this channel and helps us keep making content like this. All right, back to 1994. In March 1993, astronomers Carolyn and Eugene Shoemaker, along with David Levy, discovered something unusual. A comet that had broken apart into a chain of 21 icy fragments. They named it Shoemaker-Levy 9, and when scientists ran the calculations, the result was jaw-dropping. Every single fragment was on a direct collision course, not with Earth, but with Jupiter. From July 16th to 24th, 1994, humanity watched in real time as comet after comet slammed into Jupiter's southern hemisphere. As NASA's Hubble Space Telescope recorded, the impact scars left behind were larger than Earth itself. Superheated plumes erupted into Jupiter's stratosphere. Fragment G alone released energy estimated to be around 6 million megatons of TNT. As NASA noted, had the comet hit Earth instead, it could have created a global atmospheric disaster, much like the impact event that wiped out the dinosaurs. Jupiter absorbed that hit, silently, without a fuss. Like a cosmic bouncer turning trouble away at the door. Research modeling suggests that objects roughly 10 meters in diameter impact Jupiter around 12 to 45 times per year, compared to only once every 6 to 15 years on Earth. Jupiter is constantly being bombarded so that we don't have to be. Now, imagine that shield disappears. The comets that Jupiter currently intercepts or redirects outward, they'd have a clear path. The long-period comets falling in from the outer solar system, which Jupiter currently flings away, would no longer have anything stopping them. Over time, Earth's encounter rate with dangerous space rocks would rise. Not overnight, but the trend would be unmistakably in the wrong direction.
Here's the deepest consequence of all. The one that takes the longest to unfold, but might be the most profound. Computer simulations run by astronomers, including models published through peer-reviewed channels, suggest that without Jupiter, the orbits of the inner planets, including Earth, could gradually become more chaotic over millions of years. According to researchers, if Jupiter didn't exist, Earth's orbit could have become unstable. Over time, this instability might have pushed our planet closer to the sun, making it too hot for life to survive. That's not a certainty. Orbital mechanics over such vast timescales are complex, and current research uses the word could very deliberately. But even in more conservative models, the loss of Jupiter's stabilizing influence introduces a level of uncertainty that over geological time becomes very significant. And then there's water.
Models of solar system formation suggest the gas giant influenced the distribution of material in the protoplanetary disk. Its gravity could have prevented Earth from becoming a dry, airless world by steering icy bodies toward the inner planets, delivering water in the early epochs of planet formation. In other words, scientists believe Jupiter didn't just protect life on Earth, it may have helped create the conditions for life in the first place. The water in your oceans, the water in your glass right now, may have gotten here because Jupiter pointed it in the right direction billions of years ago. Without Jupiter from the very start, Earth might not have oceans. It might not have an atmosphere thick enough to breathe. It might be as barren and cold as Mars, or scorched as Venus. We didn't just get lucky having Jupiter. We may have needed Jupiter.
So here's where we land. If Jupiter disappeared tomorrow, the first minutes would be eerily quiet. The loss of its 95 moons would be immediate and catastrophic for those worlds. Over years and centuries, the asteroid belt would begin to stir. Over thousands of years, more dangerous space rocks would find their way inward. Over millions of years, planetary orbits could shift in unpredictable ways. And looking backward, it's entirely possible that without Jupiter, the Earth you're sitting on right now simply wouldn't exist. Jupiter is more than a distant gas giant. It is an architect of order, a regulator of threats, and perhaps even a silent contributor to Earth's ability to harbor life. And we almost never think about it.
Next time you look up and spot that steady, bright light in the night sky, no twinkle, just a calm, unwavering glow. Take a moment. That's Jupiter, doing its job, quietly keeping the chaos at bay, just like it has for 4.5 billion years. Thank you for spending this time exploring the cosmos with me. If this video opened your eyes to something you didn't know before, please share it with someone who loves space. They'll thank you for it. And if you're not subscribed yet, join our growing family of curious minds here at Cosmic Story Lab. Every week, we go somewhere extraordinary together. Now, I'll leave you with one question to sit with. Drop your answer in the comments. If Jupiter is our guardian, are there planets in other solar systems that serve the same role? And if a solar system doesn't have a giant like Jupiter, do you think life could still exist there? I want to know what you think.